Hello and welcome to ACG's Innovation Spotlight video. My name is Paul Parker Johnson. I'm the head of ACG's Cloud and Virtual Infrastructures Research Practice. And I'm joined today by Rotem Salomonovitch of Nuage Networks. Rotem is head of the product management effort for Nuage's Virtualized Network Services solution team. And we're here today to talk about an exciting new solution that Nuage has been developing that is all about bringing the principles of the cloud and virtual networking services to branch and enterprise-wide area networking solutions. And it's my understanding, as I've talked with Rotem about the solution and the team, that in developing the solution, Nuage has taken many of the principles that it's used in its virtualized services platform, or VSP solution for cloud and data center infrastructures, and blended them into the design approach being used for the VNS, which is a very innovative approach to branch and enterprise networking. But before we go too far into the VNS itself, why don't we take a few minutes and share with people some of the problems that customers have been having with the present mode of operation for branch and enterprise networks. And perhaps to do that we can use a few diagrams at the whiteboard to illustrate the point.
Thanks, BJ. Let's go ahead. So as we speak to enterprises, and at Nuage we've been investigating and looking at what enterprises have been doing over time, it was evident that little innovation has been happening in this field. Enterprise WAN networking services in general have seen in the last decade or so quite a slow set of innovations come into that space. And at Nuage we think that we can bring a whole new set of innovations into this space. Here on the whiteboard I've drawn a network that represents a typical enterprise WAN, a number of branches. And I want to focus on one of the branches to kind of describe the present mode of operations and what's happening in that branch. Then we'll span out and talk about what's happening beyond that branch.
Okay.
So currently the present mode of operation in a branch is a device that essentially is installed in that branch to connect that branch to the wide area network to become part of the enterprise WAN. That device, over time, for the last 10 years or so, we think that it's been a closed device. It's vertically integrated, it's got proprietary hardware, software, has an inbuilt control plane to socialize information to the wide area network to get its connectivity. It also has an inbuilt management plane. As you grow these devices out across the wide area network, you may have hundreds, thousands of these devices, all with this closed, vertically integrated OS deployed all across the network.
And sometimes maybe with more than one device at a single location, each with their own closed design.
Right, and it's not only depending on how many devices in that branch, but some branches have different bandwidth requirements, are located in different geographical locations, and therefore you need different devices with different capabilities across your network to get the enterprise connectivity implemented. So the first inhibitor that I think in the present mode of operation that needs to be addressed is what we call the closed platform inhibitor. We really want to look at, is there a way to simplify the platform? Is there a way to really streamline the hardware in order to deliver a unified set of services, which today are somewhat complex, device dependent, and hard to manage and implement? The second point or inhibitor that we want to discuss is really to say that if I have 100 of these devices, for example, in our example, to implement any change in those devices, configuration changes, you have to log into each one of these devices individually. Not only that, you have to be a subject matter expert to understand that device and the OS in order to make sure that you're implementing the correct changes that you desire for that branch or for the 100 branch sites that we talked about.
Right.
That is a manual process. And even if it's templated, if there's a template system that does that today, if you want to change that template, that is done manually as well. That brings error-prone solutions in here where you can make errors. And not only are these errors could be critical because they can introduce security holes, they can actually cause real service downtime.
Right.
And as you become more agile as an enterprise, those changes become more frequent and more frequent. And if you take the same amount of time to implement those changes, this is an inhibitor as you move forward in enterprise WAN networking.
Right.
The last point that I want to kind of talk about, it's really not about present mode of operation. Enterprises not only need to think about where they are today, but where they're going to go in the future.
Mm-hmm.
And the future is clear. I think the future, and as we speak to our enterprise customers, cloud and moving forward, bringing cloud into the enterprise WAN is really a way of embracing new ways of consuming applications. And if you think about the device here and how you connect this device into a cloud environment, that is not present really today. It's about stitching a device manually from the branch across the enterprise WAN
very static.
to the enterprise data center or to a public cloud. And as applications start moving around and becoming more dynamic, as users become more dynamic, that static manual process is definitely the third inhibitor that we kind of want to solve as we move forward.
Right.
There has to be a better way of connecting branches, whether these branches are physical locations as we know them, or whether these branches are virtual entities that may pop out in data centers or in public clouds. There has to be a better way of connecting users that sit out in the world to applications as they're consuming that.
Right, so it sounds like the future mode of operation, the destination enterprises want to get to, would benefit a lot from the kinds of flexibility principles that have been used in the cloud infrastructures like VSP, already deployed into data center environments, but extended out to the branch environment for those solutions.
That's a great point. I mean, the way we summarize it here in Nuage, if you want to think about that, today we've been bringing the enterprise to the cloud. Maybe a future mode of operation is to bring the cloud to the enterprise. And let's see what that means and how we've done that in the data center world.
Okay.
So we talked about the present mode of operation.
Mm-hmm.
And we talked about some of the inhibitors that enterprises, as they deploy that across the network, experience. And we kind of want to talk about what we've done here as Nuage as part of the Virtualized Services platform and how we have solved very similar problems, we think, in the cloud space.
Mm-hmm.
So the VSP proposition, the Virtualized Services platform, its aim and its goal in its design phases was to automate any network, regardless of workloads, whether they're virtualized or bare metal, and allow users to really define what they expect out of the network. Users being either individual IT users or applications, what they expect from the network when workloads are brought on and off that network.
Right.
The fundamental pillars of the VSP solution is about any virtualization platform. It could be a hypervisor independent solution.
Agnostic to
the hypervisor.
Yep.
It's agnostic to the compute management system
mm-hmm.
that is used to instantiate the workloads
mm-hmm.
and manage those workloads on the compute platforms. And it's agnostic to the networking fabric or the data center core infrastructure that already exists. And the way we implement that is by introducing a 3-layered architecture. We'll start at the bottom of the layers and then we'll move up all the way to the policy system, which is at the top of the layer. We have an agent system, we call it an endpoint. It's a virtualized routing and switching endpoint. Mm-hmm. This is really an endpoint which is lightweight, that can be embedded directly into the hypervisor or can function as a gateway. Its primary role in life is not to burden the compute workload itself. We understand that CPU and memory on compute platforms should be focused at actually moving customer traffic or workload traffic. They should not be busy processing kind of control planes and overheads of management. So we have to keep that agent or that endpoint very lightweight.
Right.
We talked about it a bit more that endpoint could be either embedded directly into the hypervisor or could function as a gateway. And either way, we need to have a unified way of managing that endpoint.
Right.
So that leads to the discussion of either having a software-only endpoint or hardware endpoint. And we need to manage that in the same fashion and enforce a common set of networking services at that endpoint. The endpoint is not only dealing with connectivity, but it offers a full set of networking services to the workload.
Things like address management.
That's right, address management through DHCP, NAT for translation functions, QoS, firewall ruling, and a whole range of networking services that workload in the data center needs. We talked about keeping that that endpoint simple.
Yep.
So where's the control plane? How come that endpoint, if it's running a control plane, where is that?
That has been streamlined.
There you go. So we've centralized the control plane. We've taken it out of that endpoint in order to keep it lightweight. We have centralized it and put it into something we call the Virtualized Services Controller. Some may think of it as the SDN controller. And it's a unified control plane, and you want to think about it as a runtime topology calculator. It calculates where the endpoints are, where the workloads are, and it makes sure that these endpoints can communicate with one another, allowing an end-to-end work kind of connectivity for particular applications in their own tenanted networks. But if we just taken the workload out, the control plane out, and simplified the endpoint, and not done any more, I think we'll be just enhancing present mode of operation. The fundamental shift here is the introduction of the third piece, which is the policy system. What's so important about the policy system? First of all, it's centralized manageability of all these endpoints. These endpoints could be distributed around the data center, across data centers, and you have a single point of managing these endpoints. All the networking services that are applied to the workloads themselves are managed centrally. That's not enough. The second point that this implements is an abstraction layer. We want to shift users and applications that are essentially IT focused, not networking focused. We want these resources or these users to express what they expect from the network and not worry about how the network implements those functions. They don't have to be tech savvy or networking engineering folks to understand the network.
So this is taking the goals of the application or the goals of the service and representing it to the network underneath on behalf of all of the applications.
And that does two things. What it does is it allows consumability of networking services. And these building blocks are consistent regardless of the implementation. If the implementation changes, it's our solution that adapts to the implementation. The user does not have to adapt to the implementation itself. So it makes what we think at Nuage, it makes networking services consumable to the IT user or IT application.
And it sounds like those design principles have been adopted in developing the VNS itself for the branch and the enterprise WAN.
Correct, exactly. And as we think about those principles I described, we call them the cloud principles. We want to see if we can take those cloud principles and bring them to the next gen or next enterprise WAN kind of evolution to solve the inhibitors that I talked about earlier on. So let's kind of transition into that and see how that works. If we go back to our branch example, before I presented the present mode of operation, now as we talk about the future mode of operation, for that same branch, how would it evolve under a new cloud principle model that I just described? If we take all these principles and move them down, the first point is, how about we make the endpoint, in this case, a branch appliance, for example. Let's streamline that. Let's make it lightweight. Let's kind of evolve it to use general purpose hardware, like we did in the data center. Really what it's performing is a gateway function, but no longer for bare metal systems. It's a gateway function for the LAN in the enterprise.
Communication services at the branch.
That's right. So, and that not only a gateway function that is doing the connectivity back into the WAN, but it's a gateway function that offers various number of networking services such as DHCP, the NAT, the QoS, the firewall rules, and the list goes on, but now not to workloads, to users. And those users may want to communicate between each other within the LAN, across the wide area network, or actually want to connect to the cloud or to the data center where applications reside.
So having the opportunity to make that so nimble or so flexible as far as what's instantiated in a given location is a phenomenal advantage.
Exactly right. That's what we're trying to achieve here under the VNS solution. And if we kind of walk through the layers before, if you recall, we had a 4-layer stack at that device at the branch. We had the hardware, the software, the controller management. Look what we've done here. We have taken the hardware and evolved it from proprietary, vertically integrated hardware device to a general purpose hardware. And there's power to doing that. The first power that kind of enterprises get by doing that is that they can leverage the obvious cost curve, or the cost reduction that we've seen in computing platforms over time as driven in data center and cloud. Second of all is, because this is general purpose, they can now opt to bring their own hardware into
their own supplier.
They become the supplier of the hardware and essentially look for a software-only solution. So it breaks the connectivity mold between the hardware and the software. We have the flexibility of having a software-only solution, bring your own hardware model. The second point that I want to kind of move to is the operating system. The operating system before was proprietary.
Yes.
We want to look towards more of an open system, an open operating system. When I say open, what we want to have is an operating system that leverages the open development that is happening in the cloud community. We want to bring all the cloud development power that is happening in the open community into that OS. So we want an OS that is optimized for general purpose hardware. We want an OS that takes small CPU and memory footprint. We want an OS that enables centralized manageability, a software that can have centralized control of it. So there's an evolution, we believe, that has to happen in the software. And that really brings me to the second point. As you have a software that really offers networking services on general purpose compute and is able to support centralized management in order to stay lightweight and simple, then you can see quite evidently now that the control has now moved from that endpoint to a centralized controller. And in this picture, as I show, that central controller is the virtual services controller. It's the same controller you just saw in the data center world.
So the same architectural principle that you can use inside the cloud is able to be used for your branch network environment.
Exactly right. So as we bring the virtualized controller to run the control plane, whether that endpoint now sits in the branch, whether that endpoint sits in the data center, or in some cloud somewhere, the control plane is consistent. But again, if we only stopped at the control plane, that doesn't fix the real problem. What we believe the real hard problem is, hard problem is about manageability. It always comes back to management, automation, making networking resources easy to consume. You don't want simplified, lightweight endpoints, but a user still having to log to 1,000 endpoints and configure those out. You want a central management system where the user interacts here, again, in expressing the behaviors of the network, which networking services should be offered to the LAN, what connectivity models should be connected to the WAN, but not worry about how these are implemented.
Right.
And again, is the power of the VSD solution. That's the same VSD you've seen in the data center space.
And it looks like the opportunity is there to give templates or policies that are applicable to different departments within the enterprise. And also, if you were, say, a service provider, different policies for different subscribers.
That's right. The policy system is multi-tenanted. It has permissions and roles, which you can allocate templates out to different users depending on the usage right. We can spend a whole amount of time about the VSD, and we'll do that, I'm sure, in subsequent sessions about that. But lastly, as we kind of streamline the operations, the control plane, the management, where this endpoint exists now can become more ephemeral. It could be a branch endpoint, it could be a cloud endpoint, it could be a data center endpoint or a headquarter endpoint. And the connectivity is automatically established. That's how we move to a cloud-enabled system that allows now enterprises to really now express the policies regardless of where their locations are, if they're cloud or not. And I think that's the real power here at VNS, what we've done here with the VNS solution. We not only solve the branch problem, as some we have done, we haven't only solved the data center problem and the cloud problem, we really brought the cloud all the way to the enterprise, solving both parts of the problem as an end-to-end ecosystem, as we understand enterprises are challenged across all their locations.
And in a common architectural framework.
And a common and open architectural framework to allow integration into the system.
That is fantastic.
So it was very clear from that discussion how the principles of the cloud are being brought to the branch and the enterprise through VNS. That was a great description.
Yeah, we really are excited about VNS. What we really think that VNS brings, to summarize, is really a set of lightweight endpoints that are based on general purpose compute. Those endpoints could either be based on compute and therefore be physical, or could be virtual, deployed in a data center cloud or any cloud.
Right.
And most importantly, those endpoints need to be centrally managed. And this is not about next-gen element management systems, but this is really thinking about how we abstract the networking services that these endpoints enforce. How do we do that in an IT application-friendly way that allows these applications to express what they require rather than worry about how this is implemented?
Right.
So the cloud principles of VNS is about these two worlds coming together, branch and cloud.
It's very clear how it's bringing a new paradigm into the branch and enterprise network. That's phenomenal. So as you look ahead for the next year or so, as you've developed the solution, you're starting to bring it to market, what do you think the uptake patterns are going to be like between, say, enterprises who want to use the solution for their own purposes, or service providers who may want to include the solution as part of their managed services offerings?
So let me tell you first, Peter, I'm very excited about VNS. We're talking to our customers and we're seeing a lot of interest. These messages are resonating really well. But really to try to categorize and look forward in the next 12 months, there could be two deployment models that we see. One is the DIY deployment model. And the DIY, do-it-yourself, enterprise want to do it by themselves. They looking at their next-gen branch architectures, and they want to go and implement a solution that it allows them to join those branch and cloud networks together. So they do that themselves. But there are some enterprises who prefer to outsource that and buy, if you like, a managed service. And that's why I think there's a great opportunity for the network operators to take that challenge up and extend what they're existing to with a new offering, a VNS offering, that delivers this capability to enterprises, maybe in a SaaS-like model, if you want to think about it that way. A software model that is consumed for doing VNS services out of the cloud, and that allows them to tie both worlds together. So we have opportunities both at the network operator world, we have opportunities at the enterprise to do it themselves, and there could be virtual network operators of the future that will come in and also maybe play in that space as well.
Yeah, it'll be fascinating to watch as the next year unfolds, and probably we'll do another one of these in a year and see what the uptake patterns have been.
I'm excited. Look forward to it.
Great. Well, thank you very much for joining us.
Great, thanks.
Yeah.